Good day, Reverend Father J. Philip Lagunay, Brothers Seminarians. I am Kaisa Loric Reganas, and this is my report on Chapter 10, the Propositional Logic Argument. So, in the past chapter, we learned how to put compound statements in symbolic form using letter to represent the atomic component, statements and connectives to represent the relationships among them. In this chapter, we will learn how to analyze and evaluate arguments involving compound statements. Here's an example of such an argument. If Shakespeare did not write the plays attributed to him, scholars would have discovered the real author by now, but they haven't done so. Therefore, Shakespeare did write those plays. So, here's the example written below. So here we go in our first topic, the 10.1 Truth Validity Test. In Chapter 9, we learned how to construct a truth table to compute the truth or falsity of a compound statement for all possible combinations of truth values of its atomic component statements. So in creating a truth table validity test, we must create a column under each rows our atomic statement and each collective. And then, kinahanglan po nato nga mo create og sakto ra nga row para mabutang tanan possible combination sa truth values para sa atomic statements, 1 atomic statement, 2 rows, 2 atomic statement, 4 rows, unya og 3 pud atomic statements, mugama po tag 8 rows and so forth and so far. So, insert truth values for the atomic statements systematically with alternating T and F in the column under the rightmost atomic statement, alternating TT and FF under the next statement to the left, and so on. So, if we were creating a truth table for the first premise alone, it would look like this. So, nga siya murag W, nya slash, nya karing murag close parenthesis or U, nya D, FFTT for the first column, then TTFF for the second column, and for the third column, bold and highlighted TT and FF, and then the fourth column, TF. So to create a truth table for the argument, we create additional columns to represent the second premise and the conclusion with a forward slash before the conclusion in order to separate it from the premises. So, mo ni siya nasa ubos, premise 1, premise 2, and the conclusion. So, as with truth tables for individual statements, each atomic components that appears more than once must have the same truth value on each row. So, sa tanang columns, magkuan-kuan gid siya, na gid siya pareha nga value dapat sa kada column. Unya, diha nimo makit-an or diha nato ma-test og false ba siya or ang both premise are true. So, we'll proceed. The test for validity is whether the conclusion can be false while the premises are both true. So, first step is to look at the column under the conclusion and flag the rows on which it is false, rows 3 and 4. So, mo na diri sa ubos, 3 and 4. So, false, false, unya, true ug false. Naputay false, true, and true, true. So, kasunod sila with regards to the rows nga karang ani dapit sa conclusion. So, TT and FF. Yan. So, now we check the premises on those rows in order to see whether they are both true. So, i-check na to ang kuan sakto ba gyud nga tinuod to siya ang argument nga gi-release. So, to determine a propositional argument is valid or true, we need to create a truth table for the argument. So, in creating this argument table, we need to put the premises on the conclusion in the top row of our truth table with a forward slash before the conclusion. And then, mohimo tag columns under each connective and each atomic statement contained in the premises and conclusion. And then, create just enough rows include in a possible combinations as what I've said kanina. And then, lastly, insert truth values for the atomic statement systematically with alternating T and F in the column under the rightmost atomic values and under the next statement to the left and so on until you have inserted truth values in every column under the atomic statement. So, next, the top chapter or the topic 10.2, truth table test short form. So, it's rather cumbersome to work with an 8-row truth table, and for every additional atomic component statement, we double the number of rows we need. So, mao ni siya nga, sa truth table test, short form ni siya, i-double na siya para muragpaspas ang pagdagan, unya, if the problem gets worse exponentially for an argument with n components, we need a table with 2 lines. So, kinahanglan na ito mo 2 lines nga table. Fortunately, there's a shorter and more efficient way to use the truth table test of validity. So, in making an argument that has 4 atomic components for which the complete truth table would require 16 lines. So, muna siya. G and H and dot, G and K, G, V, F, V, J, and then H, V, K. So, muna yung mga symbol sa karang atomic components. So, we start in the usual way, putting the premises and conclusion in a row. We put the letter T under the main connective in each premise and under the main connective in the conclusion to indicate our goal. So, we are looking for a way assign truth values to individual components that will make the premises true and the conclusion false. In other words, we are going to work back from the truth values under the main connectives in order to see whether any assignment of truth values to the components could give rise to that result. It's a bit like doing a crossword or Sudoku puzzle. So here's the example. Kani. So, nga na, mo na siya ang iyahang linya or system niya sa paggamaan ng truth table in a short form. So we have begin the conclusion disjunctive statement. Niya mo ni siya, karing na diring a part, nakita na to. Niya, notice that the first premise is a conjunction so that it can only be true if each conjunct is true, and each conjunct is a conditional statement with a false consequent, H in the first case, K in the second, so it will be true only if the antecedents J and G are also false. Okay? So, the strategy for truth table test short form. To use the short form of the truth table test for validity, we need to put the premises and the conclusion in the top row of a truth table with a slash mark before the conclusion. So, ato siyang igibutang niya magamatag columns nga maakip sa atomic statement with the connectives. So, ibutang ang T under the main connective unya ang each premise na apoy F under the main connective in the conclusion. Identify each combination of truth values for the atomic components of the conclusion that will make it false. Create a row for each combination. So, mato gagama tag row. Unya, mo put tag combination sa truth nga values in its own row, making sure that each row, each atomic component has the same truth value wherever it occurs in the argument. So, if that is so, the argument is invalid, and then, if not, the argument is valid. So, let us proceed to the 10.3 topic. So, it is the proof. So, for arguments that involve complex statements or more than a few premises, even the short version of the truth table method can be cumbersome. So, karang kani siya sa proof nato mo ni siya ang karang unsaon nato pagpangita ug valid ba or invalid ang proof nga gihatag. So if the argument is valid, however, a proof will often reveal why the conclusion follows from the premises more clearly than the truth table method does. So mo na to siya, if we can get from the premises to conclusion by valid steps, then we have shown that the conclusion follows necessarily from the premises and that whole argument is valid. Okay, so there's also a rule of inference. So a rule of inference, we have that this type of 9 basic inference rules: the modus ponens, the hypothetical syllogism, the simplification, the constructive dilemma, modus tollens, the disjunctive syllogism, the conjunction, addition, and the destructive dilemma. So in constructing a proof, We have now learned all 9 of the interference rule that we will use to take individual steps in a proof. Each rule is an argument form that we know to be valid, ensuring that each line we add to a proof follows validity from statements on the previous lines. So in constructing a proof, we need the strategies in order to make it more easier. So para mahimo na to nga masayon ang paggama or pag-construct sa strategies sa how to construct proofs, we need to have these two types of strategies which are working forward and working backward. So in working forward, look for pairs of premises to which the rules of modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, or constructive or destructive dilemma can be applied. So magamit na to sila katong mga ubang rules. And then observe whether the result can be combined with a further premise in a way that takes you closer to the conclusion. So sayon nagamay ang paggama sa forward, working forward. In working backward, we need to follow these 5 steps. So first, if the conclusion is an atomic statement, identify the premise in which the statement occurs and look for ways to get from that premise to the conclusion. If the conclusion is a compound sentence, then we need to identify the main connective and the elements it's connect. Then, if the main connective is a conditional, ato na pong pangitaon ang hypothetical syllogism. Unya, kung ang connective na po is conjunction, ato na pong pangitaon ng conjunct separately or ilahi o pangita. Then, if ang disjunction is connective gyapon, we need to look for another way. Lain na pong paagi para ma-derive ang disjuncts. Unya, gamiton to siya nga rule or addition para mahimo siyang makaderive siya through a constructive and destructive dilemma. So, let us proceed to the 10.4 equivalence. The inference rules are the basic tools we use in constructing proofs. In this section, we will acquire some additional tools that involves logical equivalence. So sa atong nakitaan diri na ay row nga gihatag. So kani nga row nagya po ni siya logically nga equivalent ug same truth value bang every combination nga gihatag sa atomic components. So if both statements are true on the same rows and false on the same rows, they are both equivalent. If their truth values differ on a single row, then they are not equivalent. The same statement forms P.Q and Q.P provide a simple example. So, from the first row, nakita nato nga the highlighted key and those highlighted 3F. So, sa second row, nakita niya po nato ang kinaunhan, highlighted T and the following highlighted 3F. So, nakita nato nga they are equivalent. Equivalent and they are both truth values. Okay, so the 10.4a, the rules of equivalence. So in the rules of equivalence, we have these 10 rules of equivalence, which is the tautology, the commutation, the distribution, contraposition, biconditional, double negation, association, De Morgan's law, implication, and the exportation. So, if ato ni siyang gamiton ang 10 equivalent rules to get all together, we can have the customary to work with a limited set because each equivalent rule specifies a pair of equivalent statement forms and the rule authorizes to replace any instance of one statement formed with corresponding instance of the other. So, 10.5, the conditional proof and reductio ad absurdum. In this section, we're going to learn 2 additional techniques that can be used in proofs. Given the rules we're using, these techniques are necessary in order to construct proofs for certain valid arguments. And even they are not necessary, they can make life easier by reducing the number of complexity of the steps we need to derive a conclusion. So 10.5a, the conditional proof. So in having this conditional proof, we need to follow these techniques and we can see the rationale for it if we examine the following argument. So mo yung argument nasa ubos. So the first premise, doesn't tell us whether A is true, but suppose it is. On that supposition, B is to C would follow. From B is to C, together with the second premise, B, weakened method of conditional proof is a way of capturing this process of thought. The method is used to prove a conditional statement. We start by assuming the antecedent, in this case A, then we use that assumption along with the premises we are given to derive the consequent C, and this justifies the conclusion A is to C. So, the summary on conditional proof. Consider using the method of conditional proof when it would help to derive a conditional statement to use the method. So, first, atong i-enter ang antecedent sa conditional statement nga imong gusto nga i-derive atong new line. So, we need also to derive the consequent of that conditional statement pinagi sa assumption or pagmix together with any previous line in the proof including the premises but not including any line in a previous conditional proof. So third, enter the conditional statement as a non-indented line. A justification, enter the lines of the conditional proof and the method CP. The statements derived within the conditional portion of the proof cannot be used after that portion has been completed. So we have here the 10.5b, reductio ad absurdum. So reductio ad absurdum is the second additional technique we're going to use, and it is also a part of the proof. Reductio ad absurdum is a Latin phrase that means a reduction to absurdity or a contradiction. So, below, we can see the method of proof. It is sometimes called the indirect proof. But I think the traditional name better captures the essence of the method. So here's the argument for which reductio ad absurdum is the most useful method. So reductio ad absurdum is a natural method to consider using when the conclusion is an atomic statement, but it can be used with compound statements as well. So for the last part, the summary. We have all completed our study of the propositional logic. So in this chapter, we learned how to analyze and evaluate propositional arguments using two methods to evaluate arguments for validity in the truth table method. So we construct a table in which the truth values of the premises and conclusion can be computed for particular assignments of truth values that will make the premises true and conclusion false. If there is such an assignment, the argument is invalid. Otherwise, it is valid in the method of proof. We derive rules and the list in the summary box that follows and is tackled then. So the 9 basic inference forms that we know to be valid, it is the 10 rules of equivalence that allows us to replace one statement by another that is logically equivalent. We may also use the techniques of conditional proof, in which we prove a conditional statement by assuming its antecedent and deriving its consequent. And reductio ad absurdum, the last part, in which we prove a statement by assuming its negation and deriving a contradiction. The construction of a proof establishes the validity of the argument, but the failure to find a proof does not establish that the argument is invalid. So that would be all for my report on Chapter 10, the Propositional Logical Argument. This is Seminarian Councilor Rick Raganas. Thank you and God bless us all.